All right, so if you're looking to learn about properties of logarithms, you've definitely come to the right place. If you're looking for something else, I'm gonna be honest, I don't know how you got here. But this video naturally follows another video I have on my channel, What are Logarithms? So if you have trouble with the basic concept of what a logarithm actually does and how to convert between exponential and logarithmic form, I highly suggest you go through that video before watching this one. So what I'm going to do in this video is talk about what are basically the six special properties with logarithms. And what I would normally do is go through examples after doing the explanation of how to use them. But I think this video is going to end up being a little longer, so I've made the examples a separate video. Links in the description if you're just looking to see worked out logarithmic equations. So let's just get started. There are six main, rules, you could say. The first group of three are like basic evaluation, right? They show up all the time, super important and super simple. So I'm going to talk about each one and give a few examples of where each property is used. So first one, I call the zero property. I don't know if that's the official name, but it makes sense to call it the zero property. And that is logarithm with base b, where b is just any number that you're able to put in the base of a logarithm, of 1 should always equal 0, right? So anytime you have a logarithm with any base, like no matter what the base is, if 1 is on the inside of the logarithm, it should always equal 0. Now let's look at a couple of examples of why it works that way, right? So you should be familiar at this point with how to convert a logarithm to exponential form. So let's convert this to exponential form to see what's actually going on. So the base of my logarithm becomes the base of my exponent. The answer for the logarithm becomes the exponent, so that 0 becomes the exponent here. And the thing inside the logarithm is my answer. So when I convert this, I get b to the 0 power equals 1. Now that's a property you should be familiar with. Anytime you take a number and make its exponent 0, that's always going to equal 1. So for example, 3 to the 0 power equals 1, 8 to the 0 power equals 1, 184 to the 0 power equals 1, right? And in logarithmic form, what does that look like? We have logarithm, where the base is whatever, where these bases, so logarithm base 3 of 1, that's going to equal 0. Logarithm base 8 of 1 is going to equal 0. Logarithm base 184 of 1 is also going to equal 0. Okay? And that's the zero property of logarithms. So hopefully that one's a bit easy. We have something called, something that's a bit similar, our next property. And I should probably number these, so this will be our first property. And I'll just label that the zero property. The next property I want to talk about is what I refer to as the identity property. So here's the rule for that one. Here, and what comes after 1 is 2, of course. So it says, say you have a logarithm of base b, where b is just some number. And so it's log base b of b, right? So that's where the base and the thing inside the logarithm are the exact same number. When that happens, we get an answer equal to 1. All right, and that's the identity property for logarithms. So in parentheses, ID for identity, property of logarithms. Again, for that one, I'm not sure if it's the official name, but I think it's the one that makes sense, because typically the identity is is kind of what gets something to 1. So let's give a couple of examples. So just like the last thing when we talked about the 0 property, let's convert this, right? Let's convert this to exponential form to see what's going on. So logarithm base b, which means b is the base of my exponent. That's going to be raised to the first power, and my answer is b, which, intuitively should make sense, right? Anything raised to the first power should just be itself, right? 7 to the first power should equal 7. 9 to the first power should equal 9. 326 to the first power should equal 326. Right? Pretty simple, pretty standard. So let's convert these to a logarithmic form to kind of, fully solidify this identity property. So logarithm base 7 of 7 equals 1. Logarithm base 9 of 9 equals 1. And then logarithm base 326 of 326. What does that equal? Well, that equals 1. Okay, so hopefully that helps you really, get down the identity property. Okay. Next is, I don't know if, again, I don't really have a name for this, but when you're solving equations, you need to know how to cancel things out. And this next property helps you do that. So when you have, plus 9, the way you would cancel that out is subtract 9 to both sides. When you have, a number multiplied by 3, how do you get rid of the 3? Well, you divide 3 to both sides. Logarithms have a similar thing, and this is something super important to memorize. It's almost always going to be the last step in solving a logarithmic equation. It shows up all the time. I can't stress that enough. Okay? So it's just this. So when you have some number b raised, where its exponent is logarithm of base b of x, that's just going to be equal to x, right? What's happening is that this base here, the base of this full exponent, and the base of the logarithm are able to cancel each other out, okay? And that's almost always how you get rid of a logarithm. And kind of let me show you how that works, okay? So say you had something like this, logarithm of 3, logarithm 3x equals 124. Okay, and we want to know how to solve this, right? If we were to convert it to exponential form, we could do this where it's, okay, 3 to the 124th equals x, something like that, and then you could solve it that way. But a lot of times your equations won't be that simple. It's this simple for the purposes of teaching. How would I get rid of this logarithm, right? How do I convert it? I'm going to end up with something like this so I can solve, but how do I get there? Well, what I do is I basically raise both sides. I use both sides of the exponent and raise it with a 3. And what that looks like is this. I'm going to make 3 the base of the exponent and make this whole thing the exponent on this side. And then whatever I do to one side, I have to do to the other. So the 3 is going to go here, and I'm going to get a 124 here. Okay? And what happens is these things will cancel out, and what I'm left on this side, what I'm left with is just an x. And that's equal to 3 to the 124. right? Which is exactly what we got here. And like I said, the numbers won't typically be as clean when you're doing logarithmic equations. So let me think of another example just to really drive home this property, because it is that important, right? And just to drive home, this is how you do it in an actual equation. Let's do logarithm base 4 of x minus 2 is equal to 14, right? So we want to figure this out. How do we do it? Well, first, we have to raise both sides and make them exponents of whatever this base is, so whatever the base of my logarithm is. So 4 on both sides is going to become the base of my exponent. Whatever was originally on each side become my exponents. Now, when you have a base and then an exponent where it's a logarithm and the base of the logarithm is the same as the base of this exponent, they cancel each other out. And what you're left with is just whatever was inside the logarithm. So x minus 2 is equal to 4 to the 14th. And then from here, you would add 2 to both sides, plus 2. And then I'm not going to do out the math. This is easy to just punch into your calculator. You would end up with x is equal to 4 to the 14th plus 2, right? So hopefully that gets down how to use this particular property of logarithms. It's really just the way you would convert a logarithm to a logarithmic form to exponential form and show work to do it. This is the actual way it happens, right? So hopefully thinking about it that way makes it easier to recognize, makes it easier to do in an actual problem. All right, so that was the first 3 property of logarithms. The next 3 are a little bit different. These were basic evaluations, right? Something that shows up all the time. Next, I'm going to go through ways you can manipulate the logarithm, change its form, change the way it looks, and be able to actually use it in an equation where you have multiple logarithms, right? Everything I've been doing so far, all the examples, just had an equation where only one logarithm existed. These next ones go through how to work with multiple. So this next rule I refer to as the product rule for logarithms. And what it says, and you want even just to like delineate, hey, we're kind of doing a different type of thing. I'm going to just do a dotted line there. So this rule says, say you have a logarithm base b, so b can be any kind of number, where you have x multiplied by y, right? So basically you have 2 things inside of a logarithm being multiplied to each other. You can split these up, right? So that can become logarithm base b of x plus logarithm base b of y. So when you're multiplying 2 things, you can split it up into log base b, where both of these logarithms need to share, need to still have the base of the original. You can change it to log base b of x, the first thing, plus logarithm base b of the second thing. And what's nice about this is, they're equivalent. So if you have these 2 things, you can bring them back to make them this thing. Okay. Now let's go through a few examples of what that looks like. So say I have something simple, logarithm base 3 of 4x. Okay? And I wanted to split that up, so I'm only left with just a single variable inside of a logarithm. Well, I can change that to becoming logarithm base 3, because that's the base we had before, of the first thing, which is 4, plus logarithm base 3 of the second thing, which was x. Right? So let's look at another example. Say I had logarithm of, whatever number. Say it was 2.8. And inside the logarithm, I had x minus 2 and x plus 4. Right? I had something like that. Still, these are two things multiplied to each other. I can change that to be logarithm of base 2.8 of the first thing, x minus 2, plus logarithm of base 2.8 of the second thing, which is x plus 4. Now, like I mentioned, if you can do something one way, you should be able to do it in the opposite direction when you have an equal sign. So let's say you start off with something like this. Logarithm of base 3. I'm just going to, because these are going to be slightly different. Logarithm base 3 of 7 x plus logarithm base 3 of 2x. Okay, I can combine these to just be a single logarithm, and that's super useful for when you're doing equations. So what I always want to check for when I'm combining things is whether the logarithms have the same base. That's the only way, only situation that I'm actually allowed to combine them. If this was log base of 8 and log base of 12, right, if they were different, I wouldn't be able to combine them. I would have to leave them this way. So since they're the same base, I can combine them to a single logarithm, and that's going to be base 3. And it's going to be logarithm of the first thing, 7x, times logarithm of the second thing, 2x. So what is 7x times 2x? Well, that is 14x squared. Okay? Let's go through just one more example of this. Let's say you had just logarithm base 8 of 2y plus logarithm base 8 of, let's go 3x. So I first check, cool, I got the same base. Dope, I can combine these. So I do a logarithm base 8, and then it's going to be the first thing multiplied by the second thing. First thing was 2y times 3x gets me 6xy. Now, just to hammer this idea home, logarithm base 9 of 3xz plus logarithm base 12 of 4x. What do I do in this situation? Nothing, right? I can't combine these. The bases are different. There is nothing to do here. All right, so that's 4 rules down. We got 2 more to go. The next rule is going to seem very similar to the one we just did. This one was called product rule because you have stuff on the inside that is being multiplied. You can change it to, a bunch of stuff that's being added. This one's called quotient rule. And let's see if you can guess what the actual property is before I write it down. So let's say we got a logarithm base b of 2 things being divided instead of multiplied. X divided by y. How do you think we might be able to split these up? I'm sure at least one of you are correct, so good job. It's going to be logarithm base b of the first thing minus logarithm base b of the second thing. And let's look at a few examples of that. So much like the first one, if I can go in one direction, I'll go in the other direction. And if I'm combining them, so if I want to go from here to here, my base needs to be the same. So let's just look at some examples. And I'll use the same numbers as I did for the previous examples. Let's do it. Log base 3. And instead of 4x, how about I do 4 divided by x? How might I split this up based on the quotient rule? Well, I have two things divided. So I can change that to logarithm base 3 of the first thing minus logarithm base 3 of the second thing, right? Super tight. Next example, let's do logarithm of 2.8. And it was, what I do? Oh, yeah, let's do x minus 2 over x plus 4. So I wanted to separate these out, right? So what do? It's going to be logarithm of my base, which is 2.8, of the first thing, which is x minus 2, minus logarithm of base 2.8 of my second thing, which is the denominator, x plus 4, right? One thing I should specify, for the product rule, order kind of didn't matter, right? Because, you know, you can move around things with addition and multiplication, right? 4 times x is the same thing as x times 4. So log base 3 of 4 plus log base 3 of x is the same thing as log base 3 of x plus log base 3 of 4. For the quotient rule, order matters, right? Because 4 divided by x is not the same as x divided by 4. So make sure the first thing is the numerator. The second thing is the denominator. Super important. So we looked at doing things going in one direction. Let's look at the opposite direction. Also important examples. So we have logarithm base 3 of 7x minus logarithm base 3 of 2x. And then we can actually figure this out. All we have to do is write it as a single logarithm. Since both the bases are the same, we're allowed to do this. Make it logarithm base 3. The first thing becomes the numerator, 7x. The second thing becomes the denominator, 2x. And actually something pretty nice about this example is we can simplify the stuff inside of the logarithm, right? Those x's cancel out and we get logarithm base 3 of 7 over 2. And this is just a straight up number. You can put that into your calculator and actually find out what the answer to that is. So let's look at another example. So we have logarithm base 8, and it's going to be 2y. Logarithm base 8, 2y, plus logarithm base 8 of 3x, or sorry, minus. It should be a minus sign. What do? Easy. Look, the bases are the same. Yay. All right. We can write it as a single logarithm. First thing becomes your numerator. Second thing becomes the denominator. Now I'm hoping this seems repetitive. If it does, that's good. That means this is becoming easier for you. And just like the last example I did, to hammer this home, log base 12 of 4y minus 2 minus log base 2 of 3x, right? What can you do with that? Absolutely nothing. Because their bases are different, you cannot combine them. All right, if you made it this far, you're almost to the end. One more rule to go. Okay? So now let's talk about what I call the power rule. So, rule 6, the power rule says, say you have a logarithm where your b is your base, b is any number, of x raised to some power a, right? X is a variable, a is a number. A can really be anything. You can change that to a multiplied by logarithm base b of x. And what that means is you can basically take this a, move it out to the front. Now let's look at just a couple of examples. Now I think that's the easiest one to kind of do. There's a lot less involved in that. It's just taking the exponent, moving it out to the front. So let's look at something like this. We need a logarithm. I'll do base 3. I guess I like that number. Let's just start simple, x to the second, right? How can we convert that to just having a single x in our logarithm? And the reason I'm showing both ways is because in some situations, you're going to want only a single variable inside of a logarithm with multiple logarithms in the equation. And sometimes you're going to want a single logarithm where everything's put into the same equation, right? So that's why I'm showing both ways. So what do you do to get this 2 out? Well, this 2 can just go straight to the front. 2 times logarithm base 3 of x. All right, let's look at another example. Say we have logarithm base 2 of maybe 9x squared. Now, we need to work with this a little bit before we can change it, right? So the way that would happen is everything inside the logarithm needs to have an exponent in order for you to actually bring the exponent out. So we can convert this to logarithm base 2 of 3x raised to the second power, and now I can use the power rule, right? So keep in mind everything needs to be on the outside, or everything in the logarithm needs to have the exponent. So then this becomes 2 logarithm base 2 of 3x. And then this can be further separated using the product rule, right? This becomes, I'll just actually do that out now. There'd be a 2 here on the outside. And then I would have on the inside of the parentheses, log base 2 of 3 plus log base 2 of x. Okay, so there are a bunch of different conversions. A lot of the time, more times than not, almost all the time, you're gonna have to do multiple rules within one equation, right? You'll see, oh, I can do product rule and power rule with this, right? Or I can combine these in so many different ways. So the next example that might be good is something like this. So say we had logarithm of 6 of x, y, and then just the y has the second power. Now here's the thing, we are not able to do power rule with this just yet. The reason why is because I can't separate that out, right? They're like, not everything has the actual exponent. So let's first use the product rule. Logarithm of base b, or base 6, my 6 is always looking at these, logarithm base 6 of the first thing, plus logarithm base 6 of the second thing, which was y squared. And now with this y squared part, I can actually do the power rule. So I bring down this log base b of x, stays log base b of x. This 2 comes out to the front, and I get 2 log base, I said b again, didn't I? Log base 6 of y. Okay, now let me go through an example where this wouldn't work, where this definitely just, you wouldn't be able to do power rule. Log base 7. My 7 doesn't look like any letters, so hopefully I don't get confused, of x squared minus 2. Right? There's no way to deal with that because we don't have like the entire thing, the x squared minus 2. That entire thing needs to have an exponent for me to take that out. What would be incorrect, right? Big X, yeah? Would be if I just tried to take only this 2 out, right? And somehow make that 2 logarithm base 7 of x minus 2. That would be super incorrect. And you can check that on a calculator by just picking a random number to be x. All right? So that is a situation where it wouldn't work. So be very careful. Now, like for the previous examples, I did something in one direction. Let me try to work it in the other direction. So we have logarithm, say we have 2 log base 6 of 3x. How would we convert that? How would we bring the 2 back in? Well, the 2 would just become the exponent of everything inside the logarithm. So I just have logarithm base 6 of 3x in parentheses, all raised to the second power. Sorry for the change from script to print. I normally like script, but people don't like reading my script. So I try to consciously write in print for these videos. Let's look at something else. So 3 logarithm base 4 of x plus 2. What we do here is simple. We have logarithm base 4. This 3 comes in, becomes the exponent of everything inside my logarithm. So we have right. Sorry about that. X plus 2. And then that's all raised to the third power. All right. And it even works with fractions. You should be familiar with fractional exponents. So let me just do one example of that. I just kind of thought of one of, let's say we have 1 over 2 logarithm base 7 of just x, right? Just like that. We can still bring that back in. So logarithm base 7, I need a new marker, logarithm base 7 of x raised to the 1/2 power. Now, what is 1/2 power? I can convert that. Logarithm base 7 of the square root of x. All right, and hopefully those are enough examples to really understand this power rule. So just to quickly go over, we got 6 main rules for a logarithm, 6 main properties that honestly, you understand how to do these, any logarithm problem will be super easy for you, like barely an inconvenience, you know. The next part, what my next video is going to be on, is just equations, actually doing logarithmic equations, right? Solving for x, that sort of deal. And these properties are the things you're using to do that, right? So hopefully that made sense. If you have any questions, throw it down in the comments. And, you know, if this video helped, hit the like button. I hear that is meant to help channels. Other than that, good luck, guys.